Back in 2005, a BP oil refinery in Texas City just exploded. It was catastrophic. 15 workers were killed and another 180 were injured. And when investigators started digging, they found something chilling. A safety system that looked great on paper, but in reality had completely stopped working. That system is called Process Safety Management. And today, we're going to talk about it.
So, March 23, 2005. A huge cloud of hydrocarbon vapor finds an ignition source and boom. The blast was so powerful it was felt for miles around. This wasn't just another industrial accident, it really became a defining moment for safety and a brutal lesson in what happens when our safety systems break down.
The human cost was just staggering. 15 people went to work that day and never came home. And on top of that, another 180 people were injured, many of them with life-altering injuries. This wasn't some freak act of nature. It was the predictable, tragic result of a system that was fundamentally broken.
And here's the thing you've got to understand. The facility actually had a program called Process Safety Management, or PSM. That's the OSHA standard specifically designed to prevent exactly this kind of disaster. The problem? It was just a binder on a shelf. It was all on paper. Understanding how it's supposed to work in practice, well, that could save your facility and it could save your life.
So, let's get into it. What exactly is this system that failed so spectacularly? What is process safety management really all about?
At its core, PSM is a regulation from OSHA, but think of it less as a rule book and more as a framework, a whole system designed to manage the unique hazards that come with highly hazardous chemicals. The entire goal is to prevent those massive, uncontrolled releases that lead to fires, explosions, and toxic nightmares.
And this distinction right here is absolutely critical. A huge finding from the Texas City investigation was that BP was actually pretty good at personal safety. Things like slips, trips, and falls. Their injury rates looked great on paper, but they had this giant corporate blind spot when it came to process safety, which isn't about one person getting hurt, it's about the entire system failing all at once.
So you might be wondering, who actually needs to follow this standard? Well, PSM is legally required for any facility that handles certain highly hazardous chemicals above a specific amount. It also kicks in for any process with 10,000 pounds or more of flammable liquids or gases. So we're talking about a whole range of industries, refineries, chemical plants, even food processors that use ammonia for refrigeration.
The PSM standard is built around 14 key elements. The best way to think about them is like 14 interconnected gears in a complex machine. If even one of those gears breaks or gets ignored, the whole safety system can grind to a halt.
Every strong system needs a solid foundation, and PSM is no different. It all starts with employee participation, because the folks on the front lines have to be deeply involved in building these programs. Next, you need your process safety information, or PSI. That's the technical blueprint for everything, your chemicals, your equipment, all of it. And finally, that information powers the process hazard analysis, or PHA. That's a team effort to ask the most important question: what can go wrong here, and are our safeguards actually good enough?
All right, so next up are the elements that keep things safe day to day. You've got to have clear, written operating procedures for every single task, especially for risky moments like startup and shutdown. Training is a big one, and it's not optional. Every employee needs documented training on the hazards they face, and it has to be refreshed every 3 years. The contractors element makes sure that every single person on site is held to the same high safety standards. And of course, a hot work permit system puts strict controls on any job that could create a spark, like welding or grinding.
Now this next group, this is all about keeping the physical plant itself under control. Mechanical integrity is a robust program to make sure that your critical equipment, pipes, pumps, vessels, is inspected and maintained properly. Then there's management of change, or MOC. And let me tell you, this one is so important. It means you have to do a formal safety review for any change, because a tiny adjustment can sometimes create a massive new hazard. And finally, a pre-startup safety review acts as that last final check before you turn on any new or modified process, just to confirm everything is safe and ready to go.
And finally, we have the elements that verify the system is working and prepare us for when it doesn't. Incident investigation means every single near miss gets analyzed to find the root cause, so it never, ever happens again. Emergency planning gives you a clear, practiced plan for that worst-case scenario. Compliance audits, which happen every 3 years, are like a formal checkup for your whole PSM program.
And the trade secrets clause is simple. Safety is more important than secrecy. Everyone gets the info they need.
So of those 14 elements, the process hazard analysis, the PHA, is really the engine that drives the whole thing. It's the proactive heart of the standard. So let's zoom in on that and see how it really works.
The entire point of a PHA is to see the future in a way. It's a structured team effort to ask, what if, over and over again. It's all about finding the potential failures in your system before they find you. It's a total shift from being reactive to being proactive about safety.
Now, OSHA gives you a few different ways to do a PHA, from simple checklists to really complex analyses. They all have their place, but for complex chemical processes, one of the most rigorous and popular methods is the Hazard and Operability Study, or what we call a HAZOP.
So how does a HAZOP actually work? Well, you start by breaking down a huge, complex system into smaller, manageable chunks called nodes. Then, you get a team of experts in a room, engineers, operators, you name it, and they systematically challenge each node using guide words like more, less, or no. They apply those words to things like flow, temperature, or pressure, and for every possible deviation, they brainstorm. What could cause it? What would happen if it did? And what safeguards do we have to stop it?
Let's make this super concrete with a simple example. Take the parameter flow. The team asks, okay, what if there's less flow? Well, the consequence is an incomplete reaction, and your safeguard is a low flow alarm. Easy enough. But what if there's no flow? Whoa, now the consequence is much worse. The reactor could overheat. See, for that you need more than an alarm. You need an interlock that automatically shuts off the heat. This structured process forces you to uncover risks and make sure your safeguards are strong enough for the consequences.
Okay, now that we understand the 14 elements and how a PSA works, let's circle all the way back to where we started, that 2005 Texas City disaster, because now we can analyze exactly what went wrong using this PSM framework.
This level of devastation wasn't caused by one single mistake. It was a cascade of failures, a domino effect, and we can trace each one back to a specific breakdown in the PSM system.
And don't just take my word for it. The U.S. Chemical Safety Board was crystal clear in its final report. They said the failure was systemic. This wasn't about a few bad operators having a bad day. This was a broken safety culture, from the corporate boardroom right down to the refinery floor.
So, let's connect the dots. First up, mechanical integrity. The high-level alarm that should have warned the operators, it was known to be faulty, but it was never fixed. The blowdown drum, which was the absolute last line of defense, it was an ancient, undersized design from the 1950s. So when the tower overfilled, this critical safety system was completely overwhelmed and just vented a massive flammable cloud right into the air.
Next, a failure in operating procedures. The written startup procedure for that tower, they just didn't follow it. And this single failure allowed operators to keep pumping thousands and thousands of gallons of flammable liquid into it for hours, with absolutely no idea that it had no place to go.
And this one is just heartbreaking. A failure in management of change. All 15 of the workers who were killed were inside temporary office trailers. Those trailers have been placed near this hazardous unit without any proper risk analysis. This one MOC failure took a major industrial accident and turned it into a mass casualty event.
And finally, let's look at training. For years, aggressive budget cuts had just gutted the training staff at the refinery. The day of the explosion, the board operator was working his 30th consecutive 12-hour shift, 30 days in a row. He was exhausted, he was unsupervised, and he was put in an impossible situation. It just goes to show how financial decisions made in an office miles away can have deadly consequences on the ground.
So what's the big takeaway here? What's the lesson from all of this? The lesson of Texas City is that process safety management cannot just be a set of rules in a binder. It has to be a living, breathing part of the culture, every single day.
This quote right here is just chilling. Months before the explosion, workers were telling consultants that the plant was a ticking time bomb. This goes right back to that very first PSM element, employee participation. The people on the front lines, they almost always see the risks first. A healthy safety culture actually listens to them.
And that brings us to the final question we should all be asking ourselves, whether you're an operator, an engineer, or a manager. At your facility, does your safety program exist only on paper, or is it really, really put into practice every single day? Because the answer to that question can be the difference between a normal shift and a disaster.
If you'd like to dive deeper into workplace safety and understand more about OSHA rules, make sure you subscribe to HSEstudy.